Hello there. 25th of March 2024. I haven't yet finished studying section 5, but I wanted to get started on the problems. So here we are. My first idea was to use the formula for transformation of the series in Q, but we have no idea how this works on that. Then I went back and read my answer to problem 15, which was rather involved. It's not an easy problem. The idea I have that I'll try following is to work on the modular points. So we have a function f of z, and that's a function of the lattice and 1/nth. And we perform two operations. The one is alpha n, it's capital N, yes. And the next one, the other one is Tn. This one, of course, maps to this. Actually, we need to take into account the factor that we get nz to minus kth. Let's disregard that first. And then here we get all the possible sublattices. Because minuscule n and capital N are co-prime. One of the things I found difficult when studying this section was to find out in practice what were this family of lattices or sublattices of 1n times L. So that required some work because I've never worked with lattices before. That's given problems throughout the book occasionally. And here it was quite acute. I had to look very deeply into it. It's not difficult, but, well, here apply Tn, and here apply alpha n to each of these guys. But then we need to find out what alpha n actually does. Oh yeah, that just does this. But there's a little problem here, because if the sublattice so we divide it into, let's say, 3 points here. just finish it off. Then the generators can be 1/nth and z, and it can be unity and a plus z nth. So that's what they in the book say. It's all the projective subgroups, additive subgroups, yeah. Oop, this was wrong. This should be -1 divided by z and unity. Why don't they give the same? When the n and capital N fail to be co-prime. I think this is part of understanding 2a, is to be able to show that there is a problem if they have a common factor, and that problem will of course be that this, or rather this lattice doesn't work. Of course, there are also sublattices if n is not prime, like if it's 6, that we take each third here and each other one here. So those lattices have to be considered as well. So this only works when n is a prime. See, I don't understand why it doesn't formally work out, because we have unity in both cases, and that's the one that gives the problems. And when I don't understand that, then I haven't really solved the problem. I just have an idea to solving it. Well, I'll have to look deeper into that. I just realized that I need to define an explicitly. So it operates on a function simply by operating on z. Next, the map on the modular point, it's only defined when we have unity as one of the coordinates here. So I actually didn't define it at all working on a modular point. Alpha is a bad one, T, I think it's usually called. So we actually need to define this in general. If we have 1 as one of the points, then we're in business. So if we now take f of this, and then take b outside, or is it b? Yeah, divide by b. How was that? That was a divided by b lies in h. I think that was the definition. Point g divided by b. And then that maps to f of span minus b divided by a on unity, g divided by b, I wonder what we should do here. Yeah, I think we should, my problem here is that I would like to take the factor minus a out, but then we get a minus a does not lie in h, nor does minus b. Oh, if one of them are real, they do. Up here, one of them are real. Here, one of them are real as well. All right. I'm not quite sure about this factor. And whichever, then this is the same lattice, but we have a new point. And a terrible factor here that we need to take into account. Of course, this is actually my intuition that the point, instead of lying here, would lie up here. So that makes perfect sense to me. I need a little work here to transform all of these and show that they agree with this. Or rather, yeah. So I'll do that on paper and then write the result. Hello, Friday 29th of March. I'm receiving guests this night, but I just have a little time. I think I've solved the problem in the meantime. Now, when we take our function f of z and transform it to the function on a modular point and operate with Tn, we get lattices of index n here. And one of the things I proved when studying the section was that along any axis, the point closest to naught can be used as one generator. And we just take all of these lattices have a real generator together with some complex number lying in H, of course. So we need to find out what n, alpha n, it's capital N, does to these lattices. And I started with that up here. So we have given a lattice, and then f of L. First we take d out, then we get this. And then it occurred to me, and that was the solution. I can see I forgot to write it here, that we prove it for all f in m of n comma chi, where chi runs through all the characters modulo n. The point being that if it holds for all of them, it will hold for m1 of level n as well. No, mk, we of course in weight k. Now, we do that here, so we can take d out here, so it's equal to d to kth chi of d times f. Now we are ready to operate with alpha n of weight k. First the determinant of the matrix to k halves, and then n times the z value to minus kth, d to kth chi of d, and then we transform the argument. Then we transform it to the capital F on this modular point, and we multiply n omega inside. Then this is what we get. And that means we've found out that we can use the same lattice, but instead of the real point here, we get 1/n of a complex generator, and any one can be used, of course. So let's see what we get. So we applied here first, where d is unity. So it gives, trivial. We could have done that, of course, without all this work, probably. And then we operate with Tn, where we sum over all matrices. This is wrong, isn't it? It should be the other way around, really. So that this has order n in L-mark. And notice, of course, I don't write span anymore, I just write the set. Okay. Oh, and that's nz. You see, it's nz here, so it should be an nz. All right, and now we do the same opposite order. First we take Tn, the definition, And here I made the same mistake, which I'll just correct. We write it as 1 divided by d theta, some generator in H. And then by the other formula, this is what we get. And now you can see there is a lovely map which just goes from one lattice to the other, from this lattice to this, multiplying the, leaving the real generator constant and multiplying the the complex generator with n, capital N. And that will of course map all of these as well. And that's really all you need to do. Then you have shown that they agree. Now we need to argue that when n and capital N and minuscule n fail to be co-prime, then it may not hold. That's because f, when we use the real, like 1 divided by n, or a complex one, then they may give different results. Except when f is symmetric, of course, then they'll give the same. So I believe this solves problem 2a.